Now that we've had the opportunity to take a look at independent and dependent events, now we're going to tie that in with mutually exclusive and inclusive or compound events. What we mean by mutually exclusive is we have two events that cannot occur at the same time. So for example, if we choose a card from a deck of cards, if we want to find the probability that we would get an even or a face card, you can't have a card that's even and a face card. So because those cannot occur at the same time with that one event, because it says or, because as you remember, we talked about how or means add, we're going to take our two individual probabilities and we're going to add them together. On the other hand, with inclusive, what inclusive means is that we have two events that can occur at that same time. So if we are choosing a card from a standard deck of cards, if we want to choose a card that is red or a 5, well, I know that I have a 5 of hearts. I also have a 5 of diamonds. That means that I have 5 and red occurring at the same time. And if we just take the probability of A plus the probability of B, we're going to count this 5 of hearts and this 5 of diamonds twice. We don't want to do that, so we subtract off the probability of it being both. So that way we make sure we don't double count it, but we're only counting it once. If we looked at this from the perspective of a Venn diagram, which you've seen before, we have wanting to include all this stuff where this is 5 and this is red. This is where it's 5 and red, and it's contained in both circles, so we want to subtract off that overlap. So if we take a look first at finding probability of mutually exclusive events, we know I'm telling you that these are mutually exclusive, so we don't have to worry about, well, are they or aren't they? That we'll get into later. So our first step we're going to do is find the probability of A. Well, in our case here, A is even, B is a face card. So first we want to find the probability of getting an even card. Well, there are 52 cards in a standard deck of cards. And the probability of getting an even number, even would be 2, 4, 6, 8, or 10. That's 5 in one suit. We have 4 suits, so 5 times 4 is 20. Then we want to find the probability of B, and we're adding them together, so the probability of a face card. Well, face cards are Jack, Queen, and King. There's 3 per suit times 4 suits is 12 out of 52. And then we go ahead and follow step 3, which is to add the two probabilities together, simplify, and convert to decimal percent. So what I'm actually going to do right now is I'm going to move this over so I have room to work with. And when I add these together, 20 plus 12 is 32 out of 52. Those are both, I know, divisible by 4. 52 divided by 4 is 13 because there's 13 in each of your 4 suits. 32 divided by 4 is 8. So now when I take 8 and I divide it by 13, I get 0.6153846154. So when I go 3 decimal places, I get 615, which is equal to 61.5%. Moving on to the next example, probability of a club or a heart. I want to take probability of club, because it can't be a club and a heart. And we're going to take the probability of a heart, and I want to add those together. Well, a fourth of the deck is club, which would be 13 out of 52, so I'm going to put it as a fourth already. And a fourth of the deck are hearts, or 13 out of 52. So a fourth plus a fourth is 2 fourths, which is equal to 1/2, which we would have 0.5 and 50%. The third one, when dealing with mutually exclusive, is 3 or an ace. You can't be a 3 and an ace, so we're going to find the probability of a 3 plus the probability of an ace. Well, we have 1 3 in each suit, so we have 4 out of 52. And we have 1 ace in each suit, so that's also 4 out of 52. And I know that's 8 out of 52. And both of those are divisible by 4. 52 divided by 4 is 13. 8 divided by 4 is 2. 2/13. If I take 2 divided by 13, I get 0.1538. So I would put 0.154. And that's equal to 15.4%. What I want you to do right now is give B a shot, enter your answers into Edpuzzle, and then check to see if you're correct. Let's take a look at this one. I know rolling a number cube, those events are mutually exclusive because 3 is not an even number, 5 is not 2, and 1 is not greater than 3. So I know that when I roll a number cube, I want to look at the probability of 3 plus the probability of even, and it helps if you write out what you're looking for. Probability of 3 is 1 out of 6. Probability of an even number is 3 out of 6 because we have 2, 4, or 6. I like to leave it unsimplified because then we have common denominators. 1 6 plus 3 6 is 4 6, which is equal to 2/3, which is equal to 0.6 repeating, so that'd be 6 6 7, which is 66.7%. A 5 or a 2, that's probability of 5 plus the probability of 2. Probability of rolling a 5 is 1 out of 6. Probability of rolling a 2 is also 1 out of 6. 1 6 plus 1 6 is 2 6, which simplifies to 1/3, which is 0.3 repeating, so 0.333, which is equal to 33.3%. Number 1 or greater than 3. So probability of 1 plus the probability of rolling greater than 3. Well, probability of 1 is 1 out of 6. Probability of greater than 3, it means I can roll a 4, a 5, or a 6, which is 3 out of 6, which is 4 6, which is equal to 2/3, which is equal to 0.667, or 66.7%.